Hello everybody, live from Paris. I like to invite you to our short presentation about Hymon cable monitoring solution. As you can see, I like to start with the French-German friendship in bleu, blanc, et rouge. And now I think it's the right time to enter into a short discussion what cable monitoring means. With me, I have Dan Keller. Dan, hello.
Hello, hi.
And as we have already mentioned, monitoring system, we called it Hymon, stands for High Volts Monitoring. So what's all about?
Yeah, Hymon in general is a modular measuring and condition assessment system, and it is can be used for both, for AC and for DC cables.
So why was Hymon developed? What's the reason for it?
The main reason or the motivation to develop Hymon are the challenges of the energy transition. So we have, for example, in Germany, the German corridor project starting, but also worldwide. We are talking about more and more HVDC cables to transport very high energy through long distances. This is one of them, was the first motivation to develop something like that. But also the second one, we have a trend in submarine cables. That means we have an increase of amount of submarine cables, but we have also an increase of the length of those submarine cables. That means these 2 points, submarine cables and HVDC land cables, are the motivation to develop a new system for monitoring and for the quality assurance of these systems.
Yeah, especially high voltage cable systems for onshore cable systems. There we also have some special requirements how to test these kind of equipment. And there we will have then a second presentation on 1st of September. I already invite you for that as well. Yeah, so at the end, what is the monitoring system doing in detail?
Yeah. In detail, or in general, today we have two functions of the system. The first function is a fault localization. That means to find a fault if a cable breakdown occurs. And the second point is a PD monitoring. That means to find small signals, but we will discuss about these topics, to find small signals in the cables in order to understand the condition of a certain cable system.
Yeah. Listen to this explanation. I have to state, meanwhile, I'm 30 years in the industry, and monitoring or failure localization, that's something I heard already decades ago. PD measurement, something what follows me through all the things I was working with, transformers, switch gears, cables. So what is really now the special things behind? So maybe let's start with localization. So after a failure, typically you go back to the cable with the test source, and then you try to apply again on high voltage, and then you have a breakdown of the residual resistance, and with this traveling wave, you can then identify the failure. So what is the system doing in difference?
You're absolutely right, Uwe. What you described is a time domain reflectometry. That means the method behind.
That's the correct wording. So.
And what we are doing, or what is the difference in the method you described, is the time. Yeah? You described a method starting after a failure, applying a certain voltage and getting the result out of that. What we do with our system is we take the first impulse. That means we have the measuring units installed permanently at the cable, and if a cable breakdown occurs, we get the first traveling waves and can directly evaluate them. And so that means you save time for determining the location of the fault.
Okay, to summarize, you have the cable breakdown, you have a very steep impulse traveling wave, and you are already capable to measure this very first and original impulse of the failure. Okay, so that was the simple part. Now let's start with the more complex one, and this is the question of PD measurement, and especially under DC. So you are claiming 525 kV DC, very interesting approach. Then when I look into the standard 60 to 70 for PD measurements, so and use this kind of process and technology, then partial discharge measurement under DC seems to be very, very difficult and if not impossible. So that means if you want to do PD measurement on DC, then you have to do something completely different. And what is this about?
Yeah, when we talk about the method of partial discharge measurement for the DC cables, we have to rethink everything what we know about partial discharge measurement. It's not a traditional partial discharge measurement what we do. Therefore, we also call the method true PD. It consists of two parts. In the first part, we determine the transfer function of a certain cable section with a length of maximum 12 kilometers. This is the first step, and this we do like every 1 hour. And how we do it? We insert a certain, or we inject a small impulse on the one side and measure it on the other side. And with that, we make the calculation. This is the first step. And the second step is, if a partial discharge, or that means if a small signal occurs, of course it is measured as well by both of the two measuring units. And we use this before determined transfer function in order to recalculate the location of each impulse and to find also what the height of a certain measured value. That means what we can evaluate at the end is not like an integral of all measured values, but what we do is we evaluate each signal of the partial discharge.
Okay, so I try to summarize. So normally you measure a reference value for the partial discharge called QISC, and based on the new approaches that you really measure the high frequency structure of the effective discharge impulse, and via the transfer function you can recalculate it. When we have now a closer view to the exponent we have here on CIGRE, then we can see this structure with red and blue devices. These are the high-frequency current transformers. And to have there a little bit more detailed information on that, I like to introduce to you also Yaroslav Shevchenko. He is the key brain behind the specific development we have done here, because that is nothing what you can find in any catalog. You have there to do also a very in-depth research and development of this kind of equipment. Yaroslav, can you please join us?
Thank you, Uwe. So here we have 3 HFCTs. So the main role of HFCT is to couple out the signal from the cable and forward it to the measuring hardware. There are of 2 colors, because with the red one we make the fault location, and with the blue ones we couple out small signals of the PD discharges. In principle, it's a passive device because this choice was made due to the reliability reasons, because nothing should break in it, because it stands at the live cable at the areas that may be inaccessible. It was optimized for multiple reasons, and it works under the main operational current of the cable that is up to 3 kiloamperes for the units that we have right now. It's a wideband sensor, so it have the frequency band from 100 kilohertz to 10 meg. And well, after all, it's just a very robust device made in Germany that carries the precious PD signal from the cable to our hardware and further to the signal processing routes. That's all from my side.
Thank you, Yaroslav. Only to explain it a little bit more in detail, so I hope we can also show this slide here. The typical application would be in this form for the terminations. Nevertheless, along the long distances, we have also to bury the HFCTs, and this is then the installation as you can see here. And most of them will be buried so that we then have the surveillance area of more than 10 kilometers until we need a new pair of sensors. So maybe Dan can join us again, because I still have two questions. Key for the application of such devices in high voltage applications, and especially under the conditions of the TSOs, is to have field experience. So my question is, what are the field experience you have already with the system, and what is now also the next steps for field testing with this kind of technology?
So to start with, we can say the first field test already started like 5 years ago, using the method of the TDR, time domain reflectometry. That means that is a long experience in the method itself. So we used at the beginning the voltage dividers for decoupling, and we learned that the interfaces are very difficult concerning the decoupling. Therefore, we developed the red Hymon. So for the towers that we see here, we have field experience since more than 1 year for the blue one. That means we have an HVDC cable equipped with it. We have also several DC cables. We have several DC cables equipped with the red Hymon, especially also submarine cables. And since this year, we also started the field test of an 110 kV AC cable in order to get also the field experience in these topics.
Yeah, the 110 kV AC cable field trial, this is something completely new for me as someone with a lot of R&D activities in the past, because it's the first field trial which is that close to the factory that I can go by bike to see then the installation in the field. So this is something really good. Okay, so as we are standing here on CIGRE, then there's always the question, so why you have this exponent on CIGRE? Yeah. What are the next steps for this kind of technology? So we have the paper, which will be presented on Wednesday morning in the B1 session, explaining a little bit more the physics and also the mathematics behind the system. Now the question is, okay, having the exponent here, what are the next steps?
Yeah, as you mentioned, the theory is now finished, and we will also explain in our paper and open the books how we make it. And during CIGRE now we make the product launch. That means we officially offer the systems, and we started as well also a more detailed explanation, as you can find on our website hymon.highvolt.com, some more detailed information about the explained methods and also the explained product portfolio. Yeah, and you find also an app there where you can calculate when is it usable and when makes sense to install such a system itself. So that are the next steps. And in the next step, that means it's like the market realization of this both products and to bring it into the real cables outside.
Yeah, so when we are looking especially to the major HVDC 525 kV cable projects, so then we expect there also the installation of the cables as well as potential monitoring systems in the next years to come. So therefore we have then already started also with the industrialization of these kind of devices, so that we are able also to deliver then the first Hymax on an industrial type tested stage then from beginning of next year. Yeah, so Thank you very much, Jaroslav and Dan, for your explanations here. I like to repeat my comment that if you are interested to learn a little bit more about how these very long cables will be tested, then I like to invite you then for our second session on Thursday, September 1st. Thank you very much for joining us here, and I like to give back then to the Communication Center of MRTV. Thank you very much.